couple steps how you want to apply this. So to find the zeros of the polynomial, first thing we do is going to see how many zeros there are by finding the highest degree we have. Okay, so that's going to be telling me how many parentheses we should have. Okay. Next step is we're going to be using this Descartes rule of sign to see how many positive and or negative zeros we will have as well. So that's using the first one we did. Third step, we want to use the rational zero theorem to find all possible zeros. So again, we're just going to list them out like we did in the last couple of examples. And then we're going to be using synthetic division / the remainder theorem. So what we did last section on 3.2, and not long division, because you do not want to do long division, and then to simplify this. Okay. Now, the whole point of using synthetic division and the remainder theorem, right, is to make it look like this. That's our goal, to break it down, because we know how to factor stuff like this. We can use our regular factoring rules, right, the AC method, the X method, or we can use the quadratic formula, right? That stuff we can break down. So our whole goal is to make kind of like this, to make it look like that. And from here, we just use our rules to break it down instead of have to do this process over and over and over again. Because trust me, it could get kind of tedious when it comes to it. Okay. So if you're wondering how in the world we're going to do this, all right? So we're going to take our time when it comes to these three questions here. Okay. Also, we'll refer again. Now, when we have a zero, let's suppose, x equaling 1 is a 0. Okay. So therefore, if I want to rewrite this like that, okay, it's going to be the opposite sign. So in factor form, it's going to be x minus 1, right? It's always the opposite sign, you see. So think of it like that one quick step before you solve, right? You would just bring it to the other side and make it positive 1. So you just bring it to the other side and make it negative 1. Okay. So when it comes to the factor form, it's always going to be the opposite sign you see going into this form here. Okay. Now, if I just confused you, don't worry, you'll see what I mean by in a little bit. Okay. Okay. So find the real zeros of the polynomial and write it in factor form. In other words, write it like this. Okay, step 1. How many zeros will we have? Well, the highest degree is 3. So we have 3 zeros. Step 1 is done. Okay, step 2. We want to use the Descartes rule of sign. So we're just going to count how many sign changes we have, right, from our first one. So -2 to 11, that's 1. That's none. And that's 2, right? So for positive zeros, I'll just put a positive zeros. We're either going to have 2 or, again, according to Descartes' rule, 2 minus an even number, which is going to be 2, right? So 2 minus 2 gives you 0. So we're going to have either 2 or 0 positive zeros. Okay? And what I mean by positive zeros is like it's going to be just, positive 1, positive 1/3, right? We have 2 or none when it comes to it. And now we're going to do the same thing for the negative zeros. But unfortunately, right, we have to flip this around. So let's do this. So odd, so it's going to change sign. This is even, so it stays the same. This is odd, so it changes sign. And again, nothing happens here because it's just no x, right, when it comes to it. Okay. And now we do how many sign changes we have. So this is positive 2 to positive 11, so no sign change. 11 to -7, that's a sign change. And negative to negative, so no sign change. So we are guaranteed to have 1 negative for sure, right, when it comes to it. And there's no subtraction because there's no even number between 0 and 1, right? So there's no even, so it's guaranteed to have 1 when it comes to it.
I'm lost. Why didn't the 11 turn from a positive to a negative?
Oh, because it's an even power.
Oh, that's right. Okay, even don't change.
Yeah,
all right.
Evens don't change, the odd will change, yeah. It just makes it easier that way when it comes to it, yeah. So that's why this one changed, because it was technically an odd power, so it changed to the negative. Yeah. Okay, so believe it or not, we are done with the easy stuff. Now let's do the difficult stuff. steps 3 and 4, and you'll see why those are the difficult ones. So we're going to figure out how many zeros we actually have, right? So just like the last couple questions, figure out what these are. So last number is a 6, first number is a 2. So all possible zeros are going to be 1 and 2. This one's going to be 6, 1, 3, and 2. I think we did this earlier as well, didn't we? Oh yeah, we did here. So we did it in our first example. Right? So since we already have it listed out, I'm just going to copy that. So if you wonder where I'm going to get this right now, we did this earlier. We had the same situation. Okay? Just so you know, for a little bit of sake of time. So all possible zeros are going to be plus or minus 1, plus or minus 1/2, plus or minus 6, plus or minus 3, plus or minus 3/2, and plus or minus 2. So that's step 3.
And the last number, it's insignificant if we added the -6 or +6 because it's going to be plus or minus no matter what.
So it really doesn't matter. You could put the negative, but it's still going to have the same factors because there's 2 ways to get that same number. Same with if this was a negative, it would still be the same. Yeah. So it's, it's kind of irrelevant because you'll get no matter what.
Got it.
Yeah. Okay. Now step 4 is what takes this the longest to do. Okay. Now, when we say we're using synthetic division / remainder theorem, so we're actually going to be using the remainder theorem a little bit more than synthetic division. So if you forgot what the remainder theorem says, is all we care about is the only way that we know that one of these is an actual zero of the polynomial is if the remainder equals 0. Meaning, if I do synthetic division, let's say, I choose 1. And if I do synthetic division here, right, and if the last number, right, the remainder is 0, it is a real 0. If it's not, therefore it's not a real 0. Okay? But remember, we also did one very special theorem that said that all I have to do is plug it in and check of our remainder and see, right? That was the last couple of examples we did last time. So it makes it much easier instead of having synthetic division over and over and over again and picking which ones when it comes to it, because believe it or not, at this point, it's just a guess and check, which is the worst part. So you're literally just picking and choosing which number you want to try and just go for it from there. Okay? Now, if you don't believe me, I'll let it up to you guys. Which one of these numbers do you think will work or is a real 0? So in other words, if we plug it in, we will get 0. What you guys want to try? Which number out of here? 6?
1.
Okay, I'll try 1 and 6. So 6 first. So let's try 6. So we're going to try C equaling 6 and see if it works. So using the remainder theorem, we're going to plug in 6 into here and see if we get 0 or not. So that's all we're going to do. So just f of 6. So minus 2 to the third plus 11, 6 squared plus 7 times 6 minus 6. All right, so we may need a calculator for these because it's going to be pretty big numbers. All right, so 6 to the third power times -2 is -432 plus 6 squared is 36 times 11 is positive 396 plus what's 7 times 6? 56, 54. Oh, way up, 42. And then minus 6. All right, let's see what we get. Oh, yeah, nice guess. We get 0. Happy face. Was that, did you know it was 6 or did you just randomly guess 6? Guess? Okay, so that's a really good guess. All right, so since we know it equals 0, right, the remainder equals 0, now we're going to do synthetic division to see what that ends up being. Okay. So what that means is, let's suppose it didn't work. So 6 did not work. We got like 5 or something. Therefore, we can cross out positive 6 and just pick another one when it comes to it. So this is what I mean. It's literally a guessing game at this point, meaning this problem could take like 10 minutes, or it can take like 20 minutes because you just guessed the wrong numbers. And there is no mathematical guess. It just it's just picking and choosing even at this point. Okay, when it comes to it. And you'll see that in a little bit, especially in the last example we have here, just lots of guessing when it comes to it. Okay. So now that we know it works, right, this works, so we know that x equaling 6 works, right? So this is what I mean by the opposite sign. So therefore, the factor will be x minus 6. Notice what I mean by the opposite sign. Okay, so in other words, I'm going to plug that into like that. Okay. But we have to figure out what the rest is. So to do so, we're going to use synthetic division to break this down. So -2, 11, 7, and 6, right? Just regular old synthetic division like we did yesterday. So bring down the first one, multiply, always add down, multiply, add down, multiply, and perfect, right? We get our 0. Okay. And now we write what this is, right? So we started with 3, so it'll be 2, 1, 0. Okay. So now what we have so far is, instead of writing it like this, we can now write it as one of our factors, which is x minus 6, and the other one is going to look like this. Okay. Which is good, right? That's our whole goal, to make it look like that, because now at this point, hopefully we can factor it using our normal factoring skills, and if we can't, we're going to just leave it just like that. Okay, so let's just see if we can or can't. Hopefully we can't. That way, that means we're finished. The best part, right? So multiplying gives you a -2 and -1. So two numbers when you multiply give you -2, and then to give you -1, I think -2 and 1 work. So we can factor it a little bit more. Okay. And this is going to be over -2x, -2x, right? Because we have that 2 there. So my first factor is going to be -2x minus 2. And then the other factor is going to be -2x plus 1, right, from here. So again, before I go any further, because I know we did a lot of information, any questions on what we just did at all? So going from 1, 2, 3, starting 4, and up to here so far.
When we're guessing to find the 0, is it possible for one or more of them to equal 0, or is it just going to be?
Oh, yes. So we can either have 2 positives, or there's no negatives, right? So it's a situation we can have that happening, yeah. So you can have plenty more. So remember, we should have a total of 3 for this example. And we actually do, right? We have 1, 2, and 3. So 3 of them will actually work out. Yeah. Does that answer your question?
Yes, thank you.
So guessing them is just, by choice. Yeah. So you just got lucky. We got 6 works. All right, so let's finish this up. So now all we're going to do is put everything together. So we're going to have, remember, this is still there. And now we're just going to put this all together. And we are done factoring. So this is what we wanted right there. It's completely factored. All that work for just that little line. So like I said, right, well, we got lucky. Juliana got lucky. She picked 6, but if it didn't work, well, we had to pick another number. And if that didn't work, well, we had to pick another number, right? Until we actually guess correctly when it comes to it. So all of this work to actually factor it to that here. And that was our goal, to factor completely. Questions on our first example. I know it's really messy and a lot, but hopefully get a little bit more comfortable in the next 2.
Is there any other shortcut other than doing all that?
Nope, unfortunately not. That's the thing, yeah. I guess the only shortcut you could do is, okay, let's suppose, so we got 6, right? So we know that's true. So we know we have at least one more that's positive. Does that make sense? So let's suppose you get lucky. We got 6 and you chose another one correctly. So therefore, you're only guaranteed 2 positives. So you can cross out all the other positives and you can choose the negatives. Does that make sense? That's the reason why this Cartridge rule of sign is so powerful, because you can kind of cross out at certain point of once you have fulfilled what you actually obligated to get. So let's suppose you started negatives. So there's only one negative that's true. So let's suppose -1 worked. So if -1 worked, all the other negatives do not work. So it cuts your search in half. Does that make sense for everybody?
Yes.
Yeah. So that's why, doing this, you may think it's difficult, you never really use it. But, if you have a list of like 15 things, it could narrow it down to like 5, which is, a lot better to deal with than just 15. Does that make sense for everybody? And, that's why this is pretty interesting when it comes to it. And you'll see it in a little bit. Trust me, it works out because it cuts the searching pretty much a lot of it in half.
And the goal is, when factoring down, is to find essentially the first number that'll do so. You don't have to continue and find all the other zeros.
If for some reason, how you simplify it, synthetic division, you get x squared, right? Then you're good. Then you could factor it normally. But unfortunately, like for the next one, it may not be always true, because we're gonna, if we do synthetic division, we'll start at x to the 3rd, which is not the format we wanted it, right? So we may have to guess again and again and again when it comes to it. But yeah.
Right. No, I understand that. I just mean, so how we factored it down right now with 6, but there's also one other positive 0 and one other negative 0. Are we also to find those other 2 zeros?
No, they're right here.
Oh, right, because
they're actually so fun fact, right? So we know x equals 6 works. So if we solve for x here, what would we get? So bring it over. So there are our 2 positives, and that's the negative we were looking for. And remember, and that's in our list, right? 6 is in our list, -1 is in our list, and 1/2 is also in our list. So if you got lucky, you chose -1, which is, in our list. So that cancels all the negatives, and now you just pick another one if you want for the positive. So you're guaranteed. So they are there. That's the key thing. There are in here. You just got to find them. If you get lucky, when it comes to it. But yeah, they're all here when it comes to it. Yeah.
Got it. Thank you.
Okay, so let's try the next one. Hopefully get a little bit more clear. So this was a little harder because it's x to the 4th. So we have to do a little bit more work when it comes to it. But let's do the exact same process we did earlier. Okay, so step 1. So we know it's going to be degree 4. So we know we now have 4 zeros, right, when it comes to it. Right, so step 2. I'll do this real quick. Okay. So we use Descartes' rule of sign. So again, how many positive zeros we have and how many negative zeros. Okay. So again, remember for this one, all we're going to do is just go from here to here. So no sign change. That's one sign change. It's no sign change. That's total of 2 sign changes, right? So looking just like the top one. So either 2 or 2 minus 2, 0. And now do the same thing for but negative x. So 4 is even, so sign doesn't change there. 3 is odd, so that's going to be minus x to the third. 2 is even, so that sign stays the same. This is odd, so that sign changes, and the last one never changes, right? And now again, we just count how many sign changes from left to right. So that's a sign change. That's not a sign change. This is a sign change. And that's not a sign change, right? So we have the same amount as the positive. We have 2, or 2 minus 2 is 0. That's what our situations we have here. All right, now we go to step 3. And step 3 was using the rational zeros. So we're going to list them all out. So last number is a 3. First number is a 2. So these aren't going to be too bad, right? So factors of 3 is just plus or minus 1, plus or minus 3. Factors of 2 are just plus or minus 1, plus or minus 2. All right, so therefore, the list we have is going to be these numbers divided by those numbers. So plus or minus 1, and then plus or minus 1/2. And then do the same thing for 3. So plus or minus 3, or plus or minus 3 over 2. So it's a little smaller list than we had last one, which is great, right, when it comes to it. All right, questions so far? So everybody just comfortable getting up to that point, and just say there. So if you're good up to here, you're about 70% done. That's the best part. Okay, so good. All right, now the hard part. Again, it is just guessing. So which one of the 8 numbers we have here, right? Because there's 1, 2, 3, 4, and then the negatives, so all 8 numbers. You guys want to try? Just pick one at random, unless you get lucky again, which should be a good thing, right?
-1.
Right, -1. So let's try x equaling -1. We're going to see if that works. Okay. And again, right, we're just going to plug it in to there and see what we get out. So f of -1. So that's going to be 2 times -1 to the 4th plus -1 to the 3rd minus 7 times -1 squared minus 3 times -1 plus 3. Okay, so this is going to still give you positive 2. This is going to be -1. This is going to be -7. This is going to be positive 3. And this is going to be positive 3. All right, see what we get. Ooh, nice job. You guys are lucky. Did you guess, or you kind of had an idea?
Just guess.
Just guess. You guys are really good guessers then. Maybe the homework's not going to be that bad if you guys are really good guessers. All right, so we know -1 does work. Yay, perfect. Okay. All right, so now let's do synthetic division to figure out what happens when we factor that down. Okay. All right, so we know, so first of all, right, x equaling -1 works. So the factor will be x plus 1, right? Opposite sign. Okay. And now let's do synthetic division to figure out what happens when we do actually factor this down. So 2, 1, -7, -3, and 3. Okay. So that's a 2. Multiply, that's -2. Add down, that's -1. Multiply those gives you 1. -6, +6, and +3, -3, and perfect, right? 0. So our new breakdown would be, again, since we started with 4, we start with 3, so it'll be 2x to the third minus x squared minus 6x plus 3, right? That's our new broken down factor. So remember, it's to be this times x plus 1. But unfortunately, unlike the last one, right, we still have x to the third. So we still don't know rules to break that down. So guess what? Back to the guessing game it goes. So, but we do know we have one less number, right? We know -1 works. So instead of 8 now, we have 7 to choose from. So back to guessing. So what's another number you guys want to see if works? Everybody scared of those fractions?
+1/2.
All right, cool. +1/2. Brave person. Let's see if +1/2 works. So again, right, all we're gonna do is plug it in and see what we get out. Hopefully it's 0. You know, if it's not, well, back to the drawing board, right? So let's see. So f of 1/2 would be 2 times 1/2 to the 4th plus 1/2 to the 3rd minus 7 times 1/2 squared minus 3 times 1/2 plus 3. Okay, let's see what we get here. So 2 to the 4th power, I think that's 16, but let me just check. Yeah, 16. So this is going to be 2 over 16 plus 2 to the 3rd is 1 over 8 minus, this is 7 over 4 minus 3 over 2 plus 3. Now again, remember, you guys use a lot of calculators, so if you want, you can just put these in decimals and simplify. I don't think this one isn't too bad to simplify. So this gives us right here 2 over 8. And then we know 2 over 8 is 1/4. You know, just simplifying that. And now, so if you notice, it kind of makes it nice and easy. So we now can put these together. So 1 minus 7 gives you -6. And then simplifying this divided by 2 gives you -3 over 2. And then putting these together, that gives you -6. Ooh, you guys are lucky. Look at that. That's beautiful, even better. Hey, don't be afraid of those fractions. Look at all that. So 1/2 does actually work as well. All right, so therefore, let's now do synthetic division. Now, this is the best part of all when it comes to that. Notice we broke this down to this and this. So now, instead of going back and doing synthetic division here, you can actually do synthetic division right here. Because remember, the whole point is to break stuff down. So we know that x equaling 1/2 is also a factor of this one because of that. So we're going to use the same numbers here. So 2, -1, -6, and 3. And we have 1/2 there. And do synthetic division there. Because remember, the whole thing is just break it down in bits and pieces. So bring the first one down, multiply, that gives you 1. Adding, that gives you 0. Multiply gives you 0. Add gives you that. Multiply gives you this. And we get the 0 we want, right? When it comes to it. Okay, so now what do we start? We start with third. So with x squared. So this is going to be 2x squared plus 0x minus 6. Okay. Or in other words, just 2x minus 6, right? Because 0 just goes away. Okay, so before we go any further, just like on top, since we know that 1/2 is a factor, so the factor will be x minus 1/2 again, right? Because it was the opposite sign of what we chose. Okay. All right, so final thing, since you guys are really good at guessing, we have to start with x plus 1, right? That was the first factor. Next is our second factor, x minus 1/2. And the last one is what we just got, 2x squared minus 6. And there we go. Factor completely. Now, if you wonder, well, can we factor this? You could use difference of squares, but I'm okay if you just leave it like that. That's good enough. Let's do it. Because if you did a difference of squares, you get your extra, your another positive and your other negative. But that's doable right there. That's just doing too much. And there we go. Here is our answer. So like I said, the most work you'll be doing is just the guessing. And again, that's just just guessing at that point when it comes to it.